Good evening, everybody. Myself, Basavaraj. I'm with SystemVerilog Solution. Today, I'm going to share my experience of migrating the UVM Ethernet UVC to the Specman. So I would be discussing the following points. So I'll just try to introduce like what is the need of the presently building a wrapper around existing UVM UVC, and how we are going to handle the UVC configuration from Specman, how the data item can be generated in Specman-E world and still can be propagated to the SystemVerilog world, and how we are going to handle the data flow from Specman-E to SystemVerilog and then to the DUT. So there is one important entity in Specman which is which is new to Specman users, which when you are using it with SystemVerilog, the e-proxy sequencer is the one which is going to handle the most of the stuff for us. So I'll just touch upon one utility which is called multi-language type map utility, which we used to map whatever the UVC configuration items are there or sequence item has to be ported from SystemVerilog to Specman. So finally, I would like to summarize whatever our experience was while migrating from SystemVerilog to Specman. So eWrapper was adopted in order to reuse the existing SystemVerilog based UVC, which was built with UVM methodology. So this is going to avoid most of our efforts to reinvent the wheel. Like we don't want to design the existing SystemVerilog UVC into Specman and again commit a lot of mistakes and qualify the verification IP, then use it in the project. So just imagine I have a Specman environment, top level environment, in which I have a readily available SystemVerilog UVC. So I just want to use it in the Specman environment. So I'll just go ahead and build a wrapper around it, and still I'll still be able to extract most of it in my Specman environment. So how we are going to achieve this one? So there is a mixed language utility which is going to help us in getting the configuration for the SystemVerilog UVC and stimulus generation data item exchange between the languages like Specman-E and the SystemVerilog. So we can also reuse most of the checkers and coverage tasks which are already built in the UVC, which are in SystemVerilog, but we can still get access to them in Specman world. So this is how our existing Ethernet UVC looks like. I have a sequence items which are driven by the SystemVerilog sequence to the agent sequencer, which in turn drives it to the agent driver, which in turn speaks to the interface, which are connected to the DUT. So this works fine when we are in SystemVerilog world completely. So what happens in like when we are in Specman, we totally depend on do action of every sequence, and the virtual sequencer driver is the one who is going to synchronize most of the sequences, which we don't have access to this one, which we don't have accessibility in SystemVerilog domain. So this is what we did to our existing Ethernet UVC. So here is the one thing which you can just see the new thing here. We have instantiated multi-language sequencer stub in existing Ethernet UVC, and we have connected it to the proxy sequencer in our system Specman world. So this entire thing in E can be considered as a single EVC, like any other EVC which I am instantiating in my Specman environment. You can just connect. You can just take a handle of this proxy sequencer in virtual sequence driver. So just bear with me. I just had some typos in like in Specman SystemVerilog world we use the sequencer. So I just typed it sequencer. This is going to be a sequence driver, basically virtual sequence driver. We take a pointer of this proxy sequence, and we can still be able to pass on each sequence items from the Specman world to the SystemVerilog. So here in this environment, E environment, we can map whatever the SE sequence items are there. We can map them. We can add our new E sequences, which works fine, and they go well with the proxy sequencer. It's not that whatever the existing SystemVerilog sequence items or sequences are there, they are going to pass through this proxy sequencer. We can build our own new sequences also in Specman. Now, how to handle the UVC configuration? Now, the fields of the config object and the transaction item should be mapped to Specman-E fields. So as you know, in a UVC, we have all the items defined as a class. So we need to have something similar to those class items in as a struct members, like a sequences in Specman. So this is the bottom section, if you can see, is a configuration item in SystemVerilog, which is equivalent is here. Like I have defined a struct TVS Ethernet config like any struct. So and I have all the fields which are configuration fields in the SystemVerilog are mapped here. So with this one, we will be able to still drive the configuration to the DUT. Now, how to drive the configuration object to this from Specman-E to the SystemVerilog? Now, we need to create an in UVM method port in an E layer through which we are going to pass the SystemVerilog UVC configuration item. The configuration object is pulled from the SVTB. It is not where it is just pulled from the TB so that you can have more control. So whatever the constraints you put in the Specman-E are propagated to the SystemVerilog TB, sitting inside the E wrapper. So what we need to do is we just simply instantiate EOSV TVS TB, which is like any other EVC which we are instantiating, and you just have to constrain it. You just set a SDL path like any other EVC. You are going to set a SDL path. Only one thing is like new thing here would be for that the agent would be, as the present discussion is mainly regarding the Specman tools, we need to set the agent name as NCSV. So this is a keyword which you need to use just to make it understand that it is going to be a SystemVerilog agent which is sitting inside deep down. Now, how about the data items generation? So mostly we are going to pass on the data items from the Specman-E. So the SV sequence item class can be mapped to E sequence items. So what we need to do is the SV sequencer stub component has to be created, which is created from the provided library name, multi-language UVM sequence, multi-language UVM sequencer stub. Okay, so declare a sequencer stub class using multi-language UVM sequencer base class. Instantiate the sequencer stub class in SV environment, which is our TVS Ethernet ENV top. So now connect the SV sequencer using assign sequencer function. Okay. So now an eProxy sequencer is created using the proxy library based type multi-language proxy sequencer driver, sequence driver. Now we need to connect the eProxy sequencer and SV sequencer stub in the ENV, which is treated as a single EVC entity. Now let's, I think this picture would explain most of our previous discussion. Now whatever in red you are seeing would be the E word, whatever in blue you are seeing would be the SystemVerilog word. So here is the eProxy sequencer. Here, whenever you do a do action, it is allowed to propagate, generate an item and pass it to the sequencer stub, multi-language sequencer stub. The item is passed to SV and the sequencer stubs. So prepare item to send. This function is invoked inside this stub to process the item, including any additional randomization. So which may be taken care specially in terms of SystemVerilog world. Now this multi-language sequencer stub would pass the item to the UVC sequencer. So which in turn it handled like a normal SystemVerilog UVM flow. Now how a sequence item looks. So this is mapped into E. We had an equivalent class definition for the data item in SystemVerilog. We just mapped it to the Specman sequence item. So it has its own virtual fields. It has its own physical fields. It has some do not generate fields, which may be constrained on the fly, or which has some randomizable fields. So you can just control like as pure Specman sequence item. You can put any constraint as per your wish. Okay. Now, how a sequencer proxy sequencer is going to handle this one? So it doesn't maintain its own queue. Basically, what it does is, as and when a do action is performed, it is just pass it on to the sequencer stub immediately. Okay. So in turn, this passes to the sequencer, UVC sequencer. Here, it maintains its own queue, and it talks to the driver, and depending on the handshake, it is going to pass on to the DUT. Now, you can also reuse the TLM ports, SystemVerilog ports, in order to get a visibility in Specman-E test bench. So what we need to do is we need to define an interface port in E, and we need to add a logic in SystemVerilog test bench to register SystemVerilog TLM interfaces with the multi-language UVM library. Now we need to connect this TLM SV ports to the E ports so that you can have a visibility in Specman-E word. Now let's talk about multi-language type map utility. What it does, it automatically maps the data items across the language. Whether it can be from E to SV or SV to E. So it takes struct or class declaration in source language, either it can be SV or E, and it can generate the code in target language. That is, might be E or SV, vice versa. Both way possible. So it matches the struct and class declarations. It serializes and deserializes the code for TLM ports. So to map the UVC object, what we need to do is we need to compile and elaborate the SystemVerilog UVC design, and we need to invoke this multi-language type map to map the required classes. What we need to pass is, like, on a compiled database, you need to pass the class or a class member which you want to convert it or to remap it to the Specman-E word. It would be with some fine tunes. It would be pretty straightforward to map most of the data items to Specman-E. So just to summarize, I would like to conclude that the existing SystemVerilog UVC can be reused in Specman-E environment with little modifications. The multi-language type map utility is going to really help us in generating sequence item and configuration items from existing SystemVerilog code. So all the sequences can be mapped to equivalent E with little bit fine tuning. And it's not only that you can only map the existing SystemVerilog sequence items. You can add the new sequence items also, and you can still add some new test cases.
Okay. Do you have any questions on this? I have just one question. So have you tried the other way around, where you take E into UVM? Have you tried taking an EVC into the UVM as well?
No.
But some of these functions you're talking about would help. So, for example,
there is a provision. We try to play with the E struct just to compare whether the equivalent class is generated or not. You just play around the data item conversion, but we try it other way around.
Okay. And just if the monitor is in UVM, you possibly want to pass data back from the UVM into the E scoreboard. Is that possible as well?
Yeah, it is possible. We need to create a event port for this one. We can just pass on. We need to define interface ports, and we can just still sample most of the SystemVerilog stuff.
Okay. Any more questions? Okay, thank you.